Today we'll be looking at a quite famous problem called word break. Famous because the solutions for it are not trivial. There are solutions explained online, even on YouTube, but I feel like those solutions are not explained with simplicity. So this is my try to break it down in a simple language. So let's start with the problem reading. So they have given us a string S and a dictionary of strings called verdict. Return true if S can be segmented into a space separated sequence of one or more dictionary words. Note that same word in the dictionary may be reused multiple times in the segmentation. So yeah, this is an interesting catch here. So they are saying we can use the same word in the dictionary to do the segmentation, but we cannot use the same segment in the string twice. So that's something they haven't given here. But if you look at the example, it can be seen. So let's say we have this string. We can see the cats was present in the verdict. So we taken it out. Then there was and the and is present here, and there is OG left, and there's nothing matching with OG directly here. But remember, they are not allowing us to consider with backtracking the dog value. So they say it's false. And also that also makes sense because imagine if we have to space separate this string. So cats space and space dog. So we are basically modifying the string. We are not really separating it. We are manipulating it. So yeah, that's not acceptable. Without wasting time, let's try to understand how we can solve this. So the solution is a bit straightforward, but yeah, because it's called a dynamic programming solution, people always get scared of it, and but which is true as well. But I guess for this problem, it could be understood in simple words. So for the solution, let's say we are going to traverse the string from the last character to the first character, and whenever we find a match, we are going to mark it as a match in our tracker or marker list. So let's say we have an extra word markers list, which would be storing the markers for every match we found. So we found an apple word here which is matching, so you mark it here. Obviously this will be of n plus 1 length, and I'll explain why n plus 1. So let's say we mark the first word wherever it was starting. So apple was starting from 1, 2, 3, 4, 5. So n minus 5, we put a true, and then rest of the values are going to be the default false values, and so on. Same, we marked it for apple. Now we come back in the string again. We found pen, so pen is matching. So we again go 3 indexes down in this marker, and we say there was a value which was matching. Then again, because we had the values already here as false, we leave them, and then in the end we are going to come here without processing any character twice and say for the apple we mark the first element in the marker list as true. Yeah, and that's basically our answer. How? So if you look at it, we marked the first word which was matching here as true, then we marked another word which was matching here true, and then another word which was matching here as true. So every time we mark these words at true, whenever we find a match in a reverse traversal, we are also going to check if the next word after this was valid or a matching word. So for example, let's take randomly pen. So for pen, because it matched, the starting position was marked as true, but also because the next word was also matching, so whatever was the length from this start index, we see another true. So this will be our the base case where each end of the words plus 1 is going to have a match. That's how we can tell the whole string matched with the words we have in our verdict. Right, so that's basically the solution. And why do we need n plus 1? Coming back to it, so the first word from the end is not going to have any following words that can be matched with it. So that's why we have n plus 1, which would be a true by default. So like we said, the next word should be true for the whole string to be true. So my last word was marked true by default, then which was non-existing, and then there was a word which existed at the last which was marked true, then the pen was marked true, and then there was apple which was marked true. So everything, so whenever my string ends, there's a matching word found here. That's why my final answer would be true, and that could be used from the start of the marker list. Yeah, so let's write this problem solution. So we say solution class, then we have, or actually let me use the boilerplate that we have there. Let me put this back. So we have a word markers array, which would be, I said, like n+1. So let's say our n was length of the string, and it's going to be initialized with falses. Like we said, we'll be marking the trues when we find a match, but for now they're all going to be false, and yeah, it should be n+1. And remember, we also need to mark our last entry in this list as true, because that's how we sequence match the words in the string. So we say n because n like whatever the length of this list, -1 would be our last index. So we say marked as true, right? Then we need to traverse the string in reverse order. So we are coming from the last index. So for that, let's do a reverse final for loop. So we say for I in range of n. Actually, we don't need to do length again. So for n-1, -1 increment, and then final stop position is also -1, right? And then what we need to do, we need to basically match it with the word dict we have. So we say forward in word dict. Now, how do we say that we got a match? So we need to come back into the string by doing a -1 with the index until we reach the length of the word that probably is a match. So we say if I plus, so it could be only be matching if the length of the current word is in current window, or is similar to current window, or same into current window. So we say if I of length word is less than equal to the length of the string, which is n. Now, why is that? Because if the word, let's say I'm at position here and my word is apple, so obviously it doesn't make sense to go further the string if the length is greater than n. And because we need to match the word, we say if s of I to I plus length of word again is equal to word. So we have basically sliced the string from the current index to the last the length of the word, and checked if it's equal. If it's equal, remember we are going to mark it in our word markers list. So we say I is equal to true. But remember, like, this could be fine for the first item, but remember we also want to maintain the chain of the words, or the sequence of words as they match. So what we can do, instead of this, we say word markers I plus length of word. So that would be the starting position of my next word, which was matched, if it was matched. So if we found a match, so let's say we try to compare pen, we try to compare apple in this word, but let's say at the first word itself, or let's say at apple itself, I found a match. I don't need to continue this for loop, at least, because already a one word match, so I will just continue. So if word markers, and how do I check that? If my current value is set to true, right? Then we break from the loop, and then simply we return, like we said, the first item or the first boolean value from our markers list. Yeah, it will be having true if all the sequence from end to start matched. Otherwise, it will be a false value, which is fine in case like. So, what is the time complexity of this problem? Let's try to understand what we are doing here. So we have our loop, which is doing n-1 iterations, which means it's n, which is equal to the length of the string. Then we have a for loop, which is basically trying to match with all the words in the verdict. Worst case, we don't find any matches, so let's say that's m. And then we have simple if conditions, but within that if condition, we are also slicing the string here. So that should have the time complexity of k, where k would be the max length word from our vertex. Yeah, like this. So yeah, our time complexity is n times m times k, and our space complexity is going to be the length of word markers, which will be n plus 1, but because 1 is constant, we say it's O of n. Yeah, that's it. Let's try to run the code actually. There might be some bugs I might have left. Word markers is equal to false into n plus 1, word markers n is equal to true. This is fine. We are coming back in the list or the string. Then we are doing a for loop on words. I plus length of word less than n, and we are matching the word by slicing it. Then we are setting it to the next marker I have in my string or my markers list, and if we set it, then we break the loop, and finally we return the whatever value we have at the start. Alright, we need to handle this. Right, there's one more. Word markers. Oh, yeah, it's not marker, it's maker. It's not maker, it's markers. Right, yeah, so that works. Let's try to submit it. Nice, beats 100%. And they're complaining about my limit, but yeah, this should be the space and time complexity, like we said. That's it. Let me know how do you find the explanation, and thanks for watching.